In today's fast-paced business world, AI is increasingly being used to augment mission-critical business tasks. The process to build AI solutions is complex and involves many stakeholders that range from business executives, data science teams, and operations. In the end, business stakeholders need a centralized inventory of all models, regardless of where each model is in the AI lifecycle. Perhaps they need something like this. Here, stakeholders can get a single view of all models by aspect, such as region, line of business, or model status. Drill downs are possible to get more information about any group of models. For example, if you need to view which models have a yellow breach status, you can click here and get a breakdown of models that fit this description along with additional information such as the owner, description, and so on. This dashboard is provided directly in Open Pages, and it is also possible to access this information from external tooling. How do we get to this desired end state? In this demo, we will show how IBM Cloud Pak for Data can be used to develop and deploy AI models, how IBM OpenScale can monitor deployed models to ensure that these models are behaving as expected, and how IBM Open Pages can surface the right information to the right people at the right time. The use case we will consider is for HR hiring predictions, where a model is used to determine whether or not a job applicant will be hired. A single company will need to hire many different job roles. Within each role, it needs to take into account different education, experience, skills, and so on. This leads to a massive amount of variation between applicants. Since you can't hire everyone, you want to direct your hiring manager's time to the applicants that are most likely to be hired. It is important to monitor this model to ensure the model is fair, performs well, and remains current. The AI lifecycle usually kicks off within Cloud Pak for Data. Here, the AI team can share a project that organizes all of the AI assets they need, from data to notebooks to the models themselves. It also has access control to help organize your team. The main data asset we'll be using is HR training data. If you click on this link, you can see all of the feature columns as well as the prediction we are hoping to get out of it, hired. You can also profile the data. Here, you can understand the range of values in each feature column. Data scientists can use AutoAI to get a rapid view of model feasibility. The tool is provided with the input data and is told to predict the hired column. AutoAI searches through multiple combinations of algorithms, algorithm parameters, and data transformations to find the best performing model. This model can be saved and deployed directly from the tool. It'll also give you a pipeline comparison to see how the model behaves with regards to certain metrics. From here, the data scientist can decide which model will work best for their dataset and use case. To deploy, all you have to do is choose the model that works best for you and click Save As. Here you can save it directly as a model or as a notebook that you can continue to work on and enhance. The other option that data scientists have is to directly use Jupyter Notebooks to perform more detailed work. Notebooks allow data scientists full freedom and flexibility to build models using the most appropriate methods, languages, and so on that they desire. This provides more control over the model building process. For example, you can see the notebook we used for this demo. Here we imported custom libraries, analyzed the data, and evaluated it on our own. The important thing is that at the end of this model building process, the data scientists will have a complete model that they believe is a contender to be put into production. For our demo, we tested and evaluated 3 different models: XGBoost, Random Forest, and Logistic Regression. Of these, XGBoost performed best. Once we've decided that, you can deploy into a deployment space. A deployment space is exactly as it sounds. It's a space that contains all of the technical assets needed to run a model. So, for our HR hiring demo, we have 2 spaces, a production space and a pre-production space. If you go into the production space, you should be able to see the technical assets that are related. Here you can see the model pipeline. If you click on this, you can see the different deployment types. And in ours, we have 4 online deployments, but it also supports batch. If you go into our pipeline here, It provides code to allow you to call the endpoint, including curl, Python, and a couple others. You can also test this manually by giving it input data here and clicking predict. These together are what we call a payload. If the model is used in production and the application sends requests to this model and gets responses back, each of these payloads gets logged. It is then ultimately available to a tool such as OpenScale that can then perform various analyses on it. From this point, the operations team can take over to deploy the model and ensure that it remains callable by the application itself. One of the primary views that AI operations teams have is here in OpenScale. You can see that I've narrowed down the deployments, so we're just looking at the production HR hiring deployment here. And this card will give an overview of the general quality, fairness, and drift metrics, but we can actually click into it to get more detail. So here you can see the breakdown in a little more detail. So for quality here, you can see different performance metrics to understand how the model's performing. And you can see it's actually performing below the threshold, so that's something we definitely want to go in and look at. You can also see drift here, which helps us understand both data and accuracy drift. It measures whether the data that we're seeing in production is similar to what we saw during training. So if there's significant differences here, then it might mean we need to retrain the model with new data, more up-to-date data. And then the last section here is fairness. So we have it configured to monitor age, gender, and ethnicity. To ensure that there's no bias in any of these categories. So we're failing pretty significantly here, the biggest one being for gender. So if we want more details on that, we can click into it. And here you can see a graph over time, so you can see there was a slight change here in the payloads that came in at this time where we actually started doing a little better. So maybe there's a change to the model, maybe this was just chance due to the way the payloads were coming in. You can also see it for age and ethnicity. For example, with age, there's a lot more variance here because we have a lot more fields for ages. There's more subsections, and then we see things have kind of tapered off. So this is something that the operations team might want to come in and take a look at. Maybe there's a problem registering the payloads and so on. So this is definitely something to keep an eye on. So we're just going to click in randomly here to get more details. So here you can see the discrepancy between male and female. It's saying that the fairness score for gender is 58.5, and it gives you the breakdown and the calculation there. But we really want to see is the payload transaction. So we want to see the individual choices that were made for each different data point that's coming in. So for each prediction we're making, we want to see more details, and we want to see, why that decision or that prediction was made. So we can see all of the payloads here, and then the ones that have bias in them have been flagged. So if we want to explain this prediction, for example, the first one here. So here you can see the different features that are actually contributing to the predictions. So these here, gender, interview score, years at current company, relevant experience, and so on, are all contributing to the yes predicted outcome, and then you see ethnicity is contributing to a no, you will not be hired predicted outcome. So this alone is a red flag. It means that it's using gender and ethnicity, which are protected fields, to make the decisions. So this is something that definitely the data science team would want to come in and look at. So just because we're monitoring for bias, maybe in this case it's not enough to do that. Maybe we need to take these fields out of the training data and train the model without them, and then do indirect bias detection. For the sake of the demo, we're just going to move on though, and you can go to the inspect section here. So here you can see for this payload all of the fields that were set, and you can actually change them here if you want preferred skills to be low or medium instead of high. You can update that, and then it'll update the predicted outcome and the confidence here. On the right here, you can run an analysis within OpenScale, and what this is going to do is it's going to find the lowest number of features that they need to change in order to get the opposite predicted outcome. So in order for this person to not be hired, what field would need to be changed, or if there's multiple fields, what would they need to be changed to and how important is that? So it's going to run the analysis on this. Alright, and here is where you see the bias. So this one was flagged for bias, and it's saying that in order for this predicted outcome to be no, all you would have to do is change gender from male to female. So that's a big red flag. You can't have that in your models, so that's this has come up and this has told you exactly what needs to change and the confidence that would come out of it. So all of these, fairness, drift, and quality, contribute to an overall health and wellness of the model. So the operations team, data scientists, anyone else can come in here and look at and understand the model performance and identify problems within it, such as this one. CloudPak for Data and Watson OpenScale are very good for developing models, monitoring models, and collecting data. But we all know that the AI lifecycle is much longer than that, and that typically it begins before the data science team even begins developing the model. Similarly, the process continues long after the model is deployed and running in production. There's a need for business audiences to keep track of which models are being used where and for what purpose, as well as getting progress updates as it's making its way through this cycle. For that, we have IBM Open Pages, which I actually showed in the very beginning of this demo. So if we go back into our production deployment here, you can see that we've already linked this model to Open Pages. So over on the left side here, you can see the Open Pages model associated, model number 39. And you can also see in this green box the communication that Open Pages sends to OpenScale. So here you can see that the model has been approved for validation, and I'll go into that a little bit more a bit later in this demo. So the other main way that OpenScale and Open Pages are able to communicate between one another is by actually sending the OpenScale metrics that we see here over to Open Pages so that the business stakeholders and other people that are maintaining the longer AI lifecycle are able to see it. So to do that, you can click on Actions, and then you can hit Send to Open Pages Now. And you can actually choose which of the metrics you're looking for, or you can send them all. You can send a PDF report. So you can choose what you're sending over to Open Pages, and then Open Pages will keep a historical database where it can actually show you how the F1 measure, how the precision, how any of these change over time. Now in Open Pages, we can see the model that's connected to our HR hiring model, model 39. So here's where you can keep metadata about the model, such as description. We have expected users, number of subjects, and things like that. So as you're moving through the workflow, this information gets filled in by the correct parties. Open Pages will keep track for you of who should be filling out what and when so that everything is in place and certified before you move on to the next step. So because we've already started this process, a lot of this information is already filled in, a lot of the required information is already in there. So you can see that here. If you scroll down to associations, here is where the connection with OpenScale is. So when we sent over those metrics, they show up here. So you can see here all the different metrics. The fairness metric for age, for example, is in breach status red as of 6/8. And then if you want more historical data, you can click into this metric. So you can see the last value is 0.703, and then if we had more data points, so if I were to submit this again tomorrow, for example, then the additional data point would show up here. So you would see collected red, the updated value, and the updated date alongside of this. So it allows you to keep a historical track of the metrics that you are sending from OpenScale. So another thing to note here is that all of these fields, everything that you're filling in through the workflow is fully customizable. So you're not using IBM's template or anything else. You can put in the process you want your business to follow and only keep track of the things that matter to you. So you're not wasting your time filling in, dummy variables that don't matter to your business. So the next logical question here is, how do we get to this state? How do we configure OpenScale, and how do you actually do that? So to do that, we used a workflow here. And for our example, we used an MRM workflow. So you can see the workflow here. We have a starting point, and then you move through this flow in order. You cannot get to the next step until you fully completed the step that you're on. So for our example, because I had already started this process for us, we actually have moved all the way through to model validation. So that's one I'll look at right now. But you can see here the type, but you can actually see, so somebody with the model validator role would have to come in and do the tasks here. So you see that we're waiting on these fields. We need a model validation report, and we need a validation data asset. So this is actually how you would customize it. You can add your own fields, you can change any of this, and then you can see the communication that it sends to the model over here on the right. So it's using the workflow in the background to actually power this model. So you can see model validation, and then you can see these two items that are missing because the model validator has not come in and completed these steps. And if you'll remember, it additionally communicated through OpenScale with a very similar message that said, we're in the model validation phase in that green box. So overall, the model inventory and workflow management capabilities of OpenPages allow business stakeholders to automatically get a grasp of the current state of any model, whether in the inception, development, or deployed phase. It also provides good governance by providing clear checks and gates that need to be passed in order to move on. And perhaps most importantly, it ensures no models make it through critical stages of the workflow without explicit approvals by the relevant stakeholders. All of this feeds into the dashboard that I had showed in the beginning. So the dashboards actually pull the information from these sources from OpenPages to actually allow you to customize your dashboard and show the relevant models and graphs that you would need at any point in time. So this concludes the brief tour of the day in the life of data science teams, AI operations, and the wider business stakeholders. IBM Cloud Pak for Data enables trustworthy AI solutions to be built easily and efficiently. It enables deployed models to be monitored in real time, and it allows all relevant model information to be shared with wider business audiences in a trustworthy manner. I wanted to thank you for your time and hope you all have a good rest of the day.